right, so this one, example 4. This is one that I just wanted you to see a problem at least that had all the stuff in this, simplifying monomial expressions technique there. So notice it is a fractional structure. All the x's have powers: x squared, x cubed, y to the negative second, y to the negative third, x to the negative second, x to the negative third. Everything has a power on it. Again, there's no need to put x to the first power on there. Okay. I did not put any 0 powers on this one, but I'll just, when we get to that point, I'll talk about how to deal with that if it happens. But first thing is, once we've written the problem out like this on our paper as a fraction, the first thing I'm looking for is this structure: something to a power to a power. And the rule says I'm supposed to rewrite the base and multiply the powers. What I want you to see here is that this is negative 2 to the first power. This is negative 2 to the first power that's being raised to those powers. So the base here is negative 2. The base here is x. So if I take a look at that, I'm going to keep negative 2 in parentheses until the negative is taken care of. Anytime you have a negative number, keep it encased in parentheses until the negative has been taken care of. And the base is negative 2. I multiply the inside 1 times the outside negative 3. That makes negative 3. The next base is x. The inside 2 times the outside negative 3 makes negative 6. So when you see this picture here, this parentheses object raised to another power, here is my parentheses object that got simplified down to this thing. What I want you to recognize is the bases, negative 2 stays negative 2 and x stays x. What changes is their powers: 1 times negative 3, 2 times negative 3. While I'm doing that, this stuff that doesn't look like that, nothing happens to it. X cubed stays x cubed, y to the negative second stays y to the negative second. On the bottom, the same thing's happening. I've got negative 2 as a base, so I'm going to put negative 2 in parentheses. Its power 1 is being multiplied by the outside power negative 2. Then I've got x as a base. It gets rewritten. And the inside power, negative 3 times outside, makes positive 6. Notice that negative times negative make a positive. Positive times negative makes negative. All the multiplication rules we've already dealt with this year are happening in this problem. We have to deal with them as they happen. Once again, if I highlight what I'm looking at, this expression here got simplified down to this. The bases were negative 2, so it's still negative 2, and x, so it's still x. The powers changed to a new power: inside 1 times outside negative 2. Inside negative 3 times outside negative 2. So make the new powers. And the x to the negative second, y to the negative third next to it, nothing's happening to it because they're not in that structure. So again, that's what I'm looking for my first simplifying step, that structure. If I see it, I fix it. If I don't see it, I just rewrite the rest of the problem down. Any concerns with that step? Once I've accomplished that step, next I want to deal with negative and 0 powers. Okay, again, there are no 0 powers here. If there was, right, let's just say that suppose there was like some z to the 0 power here. All right? I'll show you how to handle 0 power should it happen. Okay, it's really challenging and high-level math, but I think you guys can handle it. You'll be good. All right, but the negative powers obviously are here. I don't care about negative numbers, I care about negative powers. So I'm looking up at the power level here: negative 3, negative 6, that's a positive power, negative 2 is a negative power, negative 2 is a negative power, negative 2, and negative 3. Those are all the negative powers. Again, I don't care this number negative 2. I don't care about that. I'm not circling that because of that. I'm circling that because the power is negative 3 and the power is negative 2. Okay, so ready for the high-level 0 power technique? The 0 power means the answer is 1. Z to the 0 power, let me just write that over here. Z to the 0 power equals 1. It doesn't equal Z to the first, it equals 1, the number 1. Like if I said, hey, count to 10, the first number you say is 1, that's what it equals. All right? When you multiply by 1, what happens?
You just get the same.
You get the same thing, nothing changes, right?
Yeah.
So if I multiply by 1, nothing changes, which means times 1, just throw it out. That's how you deal with the 0 power.
Yes.
you take your pen or pencil and go slash, right? So again, that's the high-level math involved there to get rid of that zero power. I know it's challenging stuff. So if we continue on, everything negative power is in the wrong place. A negative power on the bottom belongs on the top. A negative power on the top belongs on the bottom. So we're just going to move those things that I got circled in green. Those things I didn't circle are going to stay right where they're at. So I'm moving -2 squared up. And once I move where it belongs, the power becomes positive. Notice this is what I moved, this guy here. The -2 base stays -2. The -2 power became a +2 power. This x to the -2 on the bottom belongs on the top, +2. Y to the -3 belongs on the top, y to the +3. This -2 to the -3 on top belongs on the bottom, so -2 to the +3. This x to the -6 on top belongs on the bottom, x to the +6. This y to the -2 on top belongs on the bottom, it's y to the +2 on the bottom. Okay, these three guys moved down, became positive powers. These three guys moved up, they became positive powers. The two guys that didn't move, x to the 3rd on top and x to the 6 on the bottom, stay right where they were. Order doesn't matter. I like numbers in front personally, but everything else after that, as long as you got everything written down, you're good. So this stayed on top, x cubed on top. This stayed on bottom, x to the 6 on the bottom. Everything in green moved from top to bottom or vice versa. That's how you deal with negative and zero powers. Zero powers, just chop them. Negative powers, move them. Positive powers, stay where they were. After you've accomplished that step, you should be left with only positive power objects. Next thing we got to deal with is multiplication. Top, simplify as much as possible. Bottom, as much as possible. Using the fact, as we've seen already, anything to a power times the same thing to a power is equal to the sum of the powers. We add the powers up. This is also the step where I'm going to evaluate numbers to powers. So let's look at -2 parentheses squared. -2 parentheses squared means -2 times -2. Two negatives make what? And 2 times 2 is? 4. So this guy right here equals 4. Okay? And then I've got on top, I've got x to the 2nd power and x to the 3rd power. I've got multiple x's, and again, when I have multiple x's, I write one x and I add the powers of the x's. So I've got 1x now, 2 plus 3 makes 5. And also on top, looking at the y's, I have only a single y object, y to the 3rd power, so nothing happens to it. If multiple things of the same thing happen, things change. If there's only one of each object, it is what it is. Same idea on the bottom. Look at, I got -2 cubed. -2 cubed means -2 times -2 times -2. 3 negatives make a negative. 2 times 2 is 4 times 2 is 8. So -2 cubed is -8. And then I'm looking at my x's. I've got x to the 6th. I've got x to the 6th. X matches x, so I get a new x. 6 plus 6 is 12. Look at my y's. I've only got one y object, y squared. So I write down y squared. Nothing happens to it. Okay, and that's how you deal with the multiplication step. At this point, you should have a number, x and y on top, a number, x and y on the bottom. All powers should be positive. And at most, you'll have one of each thing. Okay, if something's missing, that's fine too. For example, this y wasn't here, it wouldn't matter, except it's supposed to be, right? But if there weren't a y on the bottom, it's okay not to have a y on the bottom. So whatever the problem is what it is. Yep.
Why is it -8?
It's -8 because we cubed -2. That makes a total of 3 negatives. When there's an odd number of negatives, you get a negative result when you multiply. And the reason the top is positive is because we have an even number of negatives on top. All right? And finally, we're looking at reducing the fraction, and we have two different types of things happening. We have numbers, 4 and -8, and we have letters, x's and y's. Okay, different types of things are dealt with differently. Numbers are dealt with as a fraction, or reducing a fraction. If I'm looking at 4 over 8, that reduces to what fraction? Exactly, 1/2, it'll be negative because there's one negative, right? So the end result of the numerical fraction, -4 over 8, or 8 over -4, is going to be -1/2. It doesn't matter where the minus sign goes, I prefer it on top, so I usually put it on top, but if you put 1 over -2, that's also correct, there's nothing wrong with that. But again, that's just a numerical fraction, that's the reducing a fraction you've learned since like 4th or 5th grade whenever you started dealing with fractions. Okay, nothing weird about that. The letters, you want to ask yourself 2 questions. Question 1 is, where's the bigger power? So where's the bigger power for x?
On the bottom.
On the bottom, that's where x belongs. And then what's the difference of the powers? You want to subtract the big minus the small. What's 12 minus 5?
7.
7. Same thing for y. Where's the bigger power for y?
On the top.
On the top, so y belongs on top. And then we subtract, what's 3 minus 2?
Y.
1. That is your answer. That whole technique involves multiplying single-digit numbers, moving negative numbers, adding single-digit numbers, subtracting single-digit numbers. And occasionally we get a double-digit number like 12. But they're not usually rather large, right? No, nothing hard's in there, it's just a matter of doing it in that right order. And each step, if you take care of what you're supposed to take care of and just bring everything else down, that's not very hard to do. This moving things around is really easy to do. Evaluating these powers, sometimes numbers get large, use a calculator. Adding powers is easy, subtracting, determining bigger numbers is easy. Nothing's difficult in these problems. There's just lots of steps to go through, and you got to be real careful with everything that you don't leave anything off. Each step, the expression gets prettier. So this is what we started off with. It got prettier when we got rid of the parentheses. Got prettier when we got rid of negative powers. Got prettier when we got fewer letters and numbers, and then got prettier when we got the answer. So each step should get the problem a little bit simpler to look at and easier to do.